All right, this is section 5-4, medians and altitudes. So let's start with some vocabulary. Are 3 diameters of a circle concurrent? Yes, they all meet at the center. Are 2 diagonals of rectangle concurrent? No, 3 or more are concurrent. Is point C at the right the point of concurrency? Yes. Okay. So what is the median? Well, median of a triangle is a segment whose endpoints are a vertex and the midpoint of the opposite side, not necessarily perpendicular. Okay, so it goes through the vertex and the midpoint. All right, let's use the vertex. So the median of a triangle is a segment that connects the midpoint of one side to the midpoint of the adjacent side. That's false. The point of concurrency of the medians of the triangle is where they intersect. That is true. A triangle has 1 median. That's false. They have 3. All right, number 7. Circle the drawing that shows the median of AD. Bingo. All right, concurrencies of medians theorem. So the medians of a triangle are concurrent at a point, which is called the centroid of the triangle. This is 2/3 the distance from each vertex of the point to the opposite side. So for any triangle, the centroid is always inside the triangle. So this means that segment DC is 2/3 the length of segment DJ. EC is 2/3 the segment of EG. And FC is 2/3 the length of FH. All right, let's use this theorem to solve a problem. So we know that point A is the centroid of triangle XYZ. So we know that ZA then must be 2/3 the length of ZC. So substituting in from the given information, we know 9 is CA, and we know we can carry down 2/3. Multiplying both sides by the reciprocal, 3/2, gives us 27/2 for ZC. So ZC is 27/2, or you can write that as a mixed number, 13 1/2. Okay. All right, so let's read each statement and cross out the words that do not describe AD. Okay, so in this problem, we know triangle ABC is in each segment is a median and altitude or neither. Okay, so AD is a segment that extends from the vertex A to CB, which is a point A, opposite A. AD meets CD at point D, which is the midpoint of CB, since CD is congruent to DB. AD is not perpendicular to CB, so that means it's not an altitude, and it's neither an altitude nor median, so it is a median. Circle the correct statement. AD is a median. Okay, EG is neither a median nor an altitude. Okay, 15. Then CF is a segment that extends from vertex C to AB, which is opposite C. CF is perpendicular. CF must be an altitude, so an altitude is perpendicular. All right. The lines that contain the altitudes of a triangle are concurrent. The point of concurrency of the altitudes is called the orthocenter. The orthocenter of a triangle can be inside, on, or outside the triangle. So let's draw some examples of triangles. So here's an acute triangle, and let's use the points 0, 0, 2, 3, and 3, 0. So here is an acute triangle. Let's draw an obtuse triangle, 0, 0, 3, 0, and 4, 3. And let's draw a right triangle, 0, 0, 0, 3, and 4, 0. Okay, and we want to do the altitudes. So in an acute triangle, the altitude is going to be what? CF is an altitude, so it's the point from the vertex perpendicular. So here, perpendicular. Here, perpendicular. Here, perpendicular. So the point is inside for an acute. Obtuse, point, and then we want to draw perpendicular here. So perpendicular is going to go someplace like this. Here, it might go someplace outside. Okay. Okay. And for a right triangle, side perpendicular, side perpendicular, side perpendicular. Okay. So in an acute triangle, the orthocenter is inside the triangle. For a right triangle, it's at the vertex of the right angle of the triangle. And then for an obtuse, it's outside. Okay. So let's try this out here. We're going to graph triangle DEF. So D is at the point 1, 2. E is at the point 1, 6. And F is at the point 4, 2. So it looks like we have a right triangle. Here we go. All right. So DEF is a right triangle so that the orthocenter is at the vertex D. So here's D, here's E, and here's F. The altitude DF is vertical. The altitude DE is horizontal. The coordinates of the orthocenter are at 1, 2. Okay, so here are some examples. In number 25, okay, use the word altitude. So the end center intersects the angle bisectors. The orthocenter is the intersection of the altitudes. The centroid is the intersection of the medians. And the circumcenter is the intersection of the perpendicular bisectors. Okay. So the orthocenter lies in triangle ABC, which lies at the vertex A. What can you conclude about BA and BC? Well, if it's an orthocenter is located at the vertex, it must be a right triangle. So BA and AC are the sides of angle A. So my conclusion, BA must be perpendicular to AC. Okay. Triangle ABC is a right triangle. And vertex A is a right angle. And there we go, end of that section.